Ladies and gentlemen, the first item you need to understand. Here is what position can look like, okay? So if we're talking about position, there's a couple of different ways they like to make the notation on it. They can call it S of t, which means your position in terms of time. This is the most confusing one for us. They can also call it X of t. Again, that still means position versus time. Or we can just stick to what we actually know, and they call it f of x. Okay? So, hey, clarify here. Thank you. Now, so that's what position looks like. Now, we understand distance, right? After distance, if we're traveling, we measure that with velocity or speed, right? So the next one is velocity. And as we were learning, if I talk about like miles per hour, well, miles per hour is a rate. So therefore, what must velocity be? A rate, which is in calculus called a derivative. So here, when it relates to S of t, usually they call it v of t to stand for velocity. If we're dealing with x of t, they'll call it x prime because it's a derivative. And for here, just like normal, we'll call it f prime of x. So far, so good? Ooh. X prime of t. X prime of t. Okay. And then lastly, the other thing that we're going to talk about is after velocity is acceleration. Okay? You guys actually experience acceleration every day, whether you like to admit it or not, or understand it or not. Okay, well, you should, because that's how you stick to the ground. Gravity is technically acceleration. Okay? So, when we talk about acceleration, we call that a of t. Okay? And then here, we call it x double prime of t. And then here, f double prime of x. Exactly. So what it is, it's after you find that first derivative, it's taking the second derivative. Okay? So, how I like to explain this is, guys, you guys see it all the time. You've seen a football or a baseball or something being thrown. At first, we can measure the distance it's gone, right? We can also measure its speed. And the reason it comes back down is because of gravity, aka its acceleration. Okay? So, let's just talk about this example and we'll kind of talk about what we're going to do with it. So it says, a particle is moving such that the function is s of t. Any particle I want, Brandon. Negative 2t cubed plus 4t squared plus 7. Okay? And I'm going to say it's moving along the x-axis. So if we could measure something, just pretend that it's like moving back and forth along a straight line, is kind of what it's trying to say. Does that? This is an example. Yep. Okay. So we only have one page of notes today. So a particle is moving such that this is how it's moving. So this is its position, okay? And it's moving along the x-axis. I want you to first of all find v of t. Okay? So let's remember, if this is position, to find velocity, all you need to do is take the derivative. So go ahead and do that. You guys all know how to take a derivative of that? No problem. Why? And it's only been 2 months. Why are you reminding everyone, Alexa? Do you want them to hate me? Okay. So guys, something kind of cool that I want you to understand. What's its velocity at 0?
0.
0, because all I have to do if I wanted to find the initial velocity, I could just plug in 0 here, and it would tell me how fast it's moving in the beginning. What you could do is how fast is it moving after 2 seconds. So what you would do is you do f of 2, right? And it would be negative 6 times 2 squared plus 8 times 2. And then you would just get negative 6 times 4 plus 16. So therefore the velocity at 2 seconds is, negative 8. Now here's what I want you guys to understand. If it's a negative velocity, what direction should it be moving? So it's probably moving away from the origin. Okay, so this means it's moving to the left along a straight line. Okay, does that make sense to us because of the x-axis? Why?
Wouldn't a negative velocity mean it's moving towards the origin?
No. Well, okay, so depending on its initial position. So, okay, so in this case, because its initial position is 7, it's moving towards the origin, and then it's going to move away from it. So it's going to, hang on, I'll explain it in a second. I promise. Okay? Yeah. It depends on its initial position. Okay? Now guys, here's the other thing I want you to do. I want you to find A of t. So which means, take this velocity and do what? Derive it again. Because it's going to be the second derivative, and that means acceleration. So A of t is just going to be the derivative of your velocity function. There's A of t. Okay? Okay? So, using these two functions, these velocity function and this acceleration function, here's my question. Okay? What is the velocity when, why do I keep doing that? Sorry guys. That's an L. When acceleration is 0. So let's think about what they're trying to tell me. What is the velocity when acceleration is 0? Velocity is not a constant because it's continually changing. I know it's continually changing because there's variables in here. If it was a constant, it would just equal a number. So be careful by saying that it's constant. Is there anything I can pick out from this information? What about acceleration? So we know that A of t in this case should equal 0. Well, you also have another A of t equation that's right here. So what are you supposed to be doing with these two equations? So let's see what happens if I set them equal to each other. So 0 equals negative 12 t plus 8. Now guys, what are you trying to get from this piece? What is this trying to tell you? T. And what does t stand for? Time. So what this is going to do, it's going to tell you the time this particle stops accelerating. Okay? So we're going to use that time and plug it into the velocity equation. So negative 8 equals negative 12t divided by negative 12 divided by negative 12. So t does happen to equal 2/3. Okay? So again, what this means is when t equals 2/3, the acceleration is 0. So I'm just even going to put that off to the side. When t equals 2/3, the acceleration, hey, I didn't cross it, is 0. Okay? So now that I have my time, I'm going to plug it back into my velocity. So v of 2/3 now, negative 6. This is why I love fractions. Okay? So 2/3 being squared is going to be 4/9. So negative 6 times 4 over 9. Plus, if I wanted to, I could just make that 16 over 3, which I'm going to. Then I get negative 24 over 9 plus 16 over 3. Lucky enough, this does simplify, and I'm going to get negative 8 thirds plus 16 thirds. Super nice because they already have a common denominator, which means 8 thirds. This is, yeah, I didn't give you guys units, but this is the velocity when acceleration is 0. Okay?
How do we write that down?
So that's a good question. So, the velocity is 8 thirds when the acceleration is 0. So basically, all I did is I took this sentence. It says, what is the velocity when the acceleration is 0? The velocity is 8 thirds when the acceleration is 0. I literally took out what is, and I put the velocity is your answer when acceleration is 0. Okay? That's all I did. That's how I answered it. But what's the piece of information you could put in there, but that's not what they asked for? Yeah, you could put comma, this happens when t is equal to 2 thirds, but they didn't ask for it. Make sure you're answering the question. Okay? Yeah, I told you guys you would like it. Alright guys, so that's all I have to talk about. You have a homework assignment on it.
We also have no,